Hi, everybody. Thank you very much for joining us today. My name is Nicole Suri, and on behalf of MEGIN, I'd like to give you a warm welcome to this MEGIN Masterclass with our guest speakers, Dr. Tobias Scherg and Dr. Harold Bornfleth from BESA. We will have some concluding remarks by Lisa Hele from MEGIN. Just before we start, and while people are still joining, we have a few housekeeping rules to go over. Please use the Q&A button on your screen to send in your questions at any time during the masterclass. There will be time for our guest presenters to answer any questions you may have at the end of this session. Any questions unanswered, we will try and respond in writing after the session. I'd like to take this opportunity to remind you that this webinar is being recorded with the permission of our speaker and will be available on the MEGIN website to watch on demand. And finally, just a reminder to please adhere to the MEGIN Code of Conduct for webinars and engage respectfully online. So without further ado, it gives me great pleasure to hand over to our guest presenters who will officially kick off the webinar. Thank you.
So thank you, Nicole, and it's nice being here and giving the opportunity to give a little bit insight to our work. My name is Tobias Scherg. Next to me is Harold Bornfleth, and yeah, so I think we start over with the webinar. The topic of the webinar today would be how the two hardware and software leaders in the world basically combined their strengths and streamlined MEG analysis. We structured the talk like we wanted to show how we came together, why is it useful to use MEG in the epilepsy workflow, shortcomings on available solutions out there, then innovations for our new solution, and then we will give the longest part of the whole webinar. We will show a walkthrough through the software. We will have an outlook presented by Lisa, and finally come back to your questions you may enter into the chat during the talk. So let's start over with how BESA and MEGIN came together. Until 2016, BESA and MEGIN had, that was to that time point, it was still Elekta. We had a ad hoc basis that MEGIN delivered software to its customers on a as per need basis. Both companies were pretty much aware of each other and we respected each other, but we didn't work that closely together like we do today. In 2016, we were approached by MEGIN about a possible collaboration, and a memorandum of understanding was drafted and finally signed in June. And from that time point on, we really got stepwise to the today's collaboration, which was then finally made official in 2017 while the ISACM meeting in Sendai, Japan. And from that time point on, we started with the implementation and had several customer meetings in order to develop the whole program in a way that it will find its market in the end. And last year we had final decisions on last adjustments to finalize the software. And this year, given the regulatory is working out as we planned, altogether, we want to go to the market. So on the other side, the most interesting question is, why is MEG pretty interesting to the analysis of epilepsy? So first of all, MEG plays a major role in the pre-surgical evaluation of a patient, and that has several reasons. For one, we have that MEG is a diagnostic imaging modality which provides very sensitive, time-sensitive information because of its real-time nature. We have a useful, non-invasive, direct tool which clinicians can use in order to understand the epilepsy more precisely. MEG can be used as functional mapping, for example. We see here sensor processing, motor control, and language. This is because we want, if we plan for surgery, we need to know where these function areas are coded in the brain, and MEG can be very helpful for that. MEG offers a very high accuracy, and we have the possibility to combine MEG and EEG measurements. So altogether, MEG is a powerful tool for pre-surgical evaluation, and MEG is also used in research on dementia and autism, as well as traumatic brain injury. So you can see there's a lot of development in the MEG world, and we want to be part of that thing. And that's the reason why we drafted the software together with MEGIN, and we were driven by shortcomings of other solutions on the market. So What was missing in current software solutions? So we had solutions out on the market, but they had some limitations. For example, information was spread over several sub-programs in different windows, and it was not presented in a comprehensive way. So a lot of manual interaction was not necessary, and tweaking is required. No workflow guidance through the analysis steps, as well as it was not always easy to revisit previous analyzed data for confidence building. So when it comes to spike analysis after localization and so on, you want to maybe revisit your data in order to see whether you did it good. The whole results are pretty robust, and that was not so easy to achieve that goal. Author analysis takes up a lot of time. The manual steps like copying between the different programs is a pretty good source for error in the end. So how could we address these problems? And this leads us actually to the innovation for new solutions we want to provide with the new software. First of all, we have a workflow approach. We start over with the patient list, go for the review. You see the respective screenshots here. You will see the more detail during the walkthrough software. And we have a grouping work step. This is all pre-processing in the end. And what we then do for the source localization, we start over with a model work step to localize the whole thing, then visualize everything, and finally put it in a report that can also be exported to DICOM, for example, to go in the pre-surgical evaluation routine. And now I will turn over to Harold because he is responsible for that software, and he will give you some more details about some other technical features we have implemented here. So please.
Thank you. Yeah, thanks, Toby. Yeah, so welcome from me as well. And yeah, now I'm just going to talk a little bit about some of the particular sort of innovations that we put into the software. The first thing is that we now have a very easy way of co-registering your MRI data with the MEG scan, and this is usually the first thing that you do. So we have a skin surface that's reconstructed from the MRI, and we have a digitized sensor cloud from the MEG scan, and these are automatically co-registered in the software. Then another thing that we sometimes have that reviewing the data can be quite time-consuming since there are so many channels in MEG. And however, quite often the same signal appears on many neighboring channels, as you can see here on the right-hand side. And if we first transform the signal into the brain from the sensor level using a number of predefined sources, like shown on here on the left, that are distributed over the whole cortex, we can actually reduce the number of channels drastically. And then we can review all data on one screen, as an example here. And this type of transformation we call a source montage. There's actually just to have a publication press that MEGIN and BESA did together, and it's just coming out, so watch out for that. Yeah, and the next thing we're doing is that, of course, artifacts are generally a problem when trying to review the data, so they can distort our view, and with this new software, artifacts can be corrected on the fly. So in a fully automated way. For example, here you can see some data before and after EOG correction with an automated correction. And the same holds true for ECG artifacts. So here you can see every second or so we see these spikes coming up with the ECG, and potentially this is even more problematic because the timing of the ECG spike resembles actually epileptic spikes. So that may obscure any clinically relevant events. And again, we can simply correct them in an automated fashion. And another thing that is important is locating the timing of the spike. If you find a spike, you want to find the spike peak. And that's important also for the onset analysis of the spike, but as well for successfully grouping the different spikes into that are of similar origin into the same groups. So if we have a good alignment of single spikes, then it's also possible to average them, and that will increase our signal-to-noise ratio, and again gives us a better analysis perspective. So MEG Review can help you here because the spike peak is actually found automatically. So you click here on the left, for example, then the program will check all the neighboring channels in the montage, find the one with the highest signal, and look for the peak in that particular channel. and then you get a great alignment of different spikes of similar type. And again, we offer the potentially method to review these spikes together. So you can see, for example, in this case, we have two quite similar topographies, and these can then be automatically grouped into the same group by the program and automatically averaged as well. So nothing to be done on the user side. Right. Another thing that we usually do when we review epileptic data is a whole head mapping. So we try and map the signals on the skin or the sensor level. And if you're looking at a typical scenario of a sort of current dipole activity that flows from this point here along this line, this will generate a magnetic field that we call H here. So there's a magnetic flux as well as the electric field. So the magnetic flux, of course, as you probably know, can be detected at the sensor level of the MEG, because the great thing about this signal is that it just does not get held up at the skull. It kind of can transform that skull and be detected quite nicely on the sensor level. So this is great and gives us high accuracy for MEG. But one issue, if you then map it on the sensor level, is that potentially the head position may be different for different people in the helmet, and also it would be quite nice if we can compare the maps of EEG and MEG directly on the skin level. So what we can do is that we use the cortical remapping to transform the signals again to the skin level, and then we can directly compare EEG and MEG maps for the same spikes, like in this example here. Also, this can be done without showing the sensor level, and you can see the different types of field patterns. So here the orthogonality of MEG pattern, of the flux pattern, to the voltage pattern that we see here on the skin. Yeah, then of course we get to localizing spikes, and at that point it's sometimes tricky to figure out when is my fit good enough, or is my event even a good spike for fitting? Has it even got a dipolar character? And this is where the traffic light concept for fit quality comes into play. So it can help you to answer these questions using the traffic lights approach, and also it can tell you whether you can move maybe from the fitting position that you've chosen to an earlier time during the onset of the spike, and you may still get a reliable fit result. For this purpose, the MEG review traffic light has 4 key parameters. The first one is chi-squared, so how dipolar is the topography. The next one is the confidence volume, so what's the estimated localization error due to the noise level. Then the goodness of fit, how much of the data varies is actually explained by my model, and also the magnitude. Then the estimated dipole strength can also be used to estimate, is this actually a physiological activity. So these 4 taken together then give us the fit quality statistics, and you can see in this example that if there's already one yellow value, then the overall statistics will also be yellow. Okay, so these are kind of some of the innovative things that were implemented here, and I would now like to just show this kind of in a direct presentation of the software prototype. We actually pre-recorded this yesterday, but it just runs and we can talk you through this. So first of all, we get to the welcome screen when you start the software, then you click accept, and then now we're seeing here the patient list. So this is the patient list view of the MEG review, and we can see at the top the workflow items. So then we have the patient ID on the left-hand side. I can switch between patients using here this simply clicking on them. And then we have the name, the date of birth, gender, the latest MEG study that was conducted. And then we have 3 columns that show the segmentation state of the MRI, the co-registration of the MRI, and also the study state of the MEG scan. So currently these are still red for this patient. And now I want to do the first thing, which is co-register my MRI with the MEG scan. And in order to do this, I simply click on the study card on the MRI and the corresponding MEG scan I want to co-register, and then click the co-register button. And the next thing that happens is the BESA MRI tool starts a co-registration workflow. First thing is that I get to the view of the fiducials. These have already been predefined, but I can just show you how that can be changed. So simply click on this and then I can adjust it. And now go to the next step. And the next one is already the fit of the surface points that have been digitized and sent over from MEG review, and now I get the co-registered data set already. So the mean distance error is quite small. I can have a look at this to check what it looks like, and we can also switch off the MEG sensors to get a better look of the surface points, and then potentially we can do some adjustments manually if we want to. So if you look at this, then you can see how the MEG scan sensors now move with respect to the head when I adjust them. But actually, I'm going to keep with the initial fit that was actually very reliable, and then pressing the finish brings me back to the patient list. And now I can see that I've got some solid lines, solid line connecting my MRI with the epilepsy scan, which means it's co-registered. However, I've got a few other scans there, and I also want to co-register them. I just control-click to select them all, and press 1 of the co-register button, and this co-registration is then simply copied since they all had the exact same digitization points. Okay, so now let's start a review on the epilepsy case, and we're going to then walk through this workflow using the different workflow steps. And the first thing I'm going to do is review my raw data. So at the top, I can see the MEG channels. Then they're already transformed to a source montage, which gives me an overview of all channels with my 58 source channels that have been defined in the brain. At the bottom, I can see the EEG. This is in a longitudinal bipolar montage, and I'll scale it up a little bit just by mouse drag, and then go back to the top where I have my review tab for the MEG channels. So the top row that you see holds the so-called quick buttons, which are for actions that happen quite frequently. One of them could be using filters. So changing a filter here is just one button click to the 2 to 35 Hertz filter, for example. More filters are available from that drop down. And if I want to adjust the filter, I can go to the left. And then I have my playground where I can really change any individual filter and play around and see directly how it changes in the source waveforms here. So say I'm going to go to a 1 Hertz to a 35 Hertz filter. And now I could either save this, or I can just leave it for this session, then close this sidebar widget on the left. And I can see there's a new button there at the top that shows me the 1 to 35 filter. Okay, the quick button group, this one is the different montages. I'm gonna now select a magnetometer selection that shows me an overview of the magnetometers, or I can just go straight to the sensor level. This shows me all the sensors, and I wanna take out the bio and the EEG channels just to show the MEG channels. That's still too much. So on the right hand, I can switch to channel subsets. So this is the left frontal, this is the left temporal, and maybe I want to go back to the left frontal. So here I can really work with the subsets of the recorded sensors, but I can uncheck it again to see all the sensors too. So I'm going to go back to the overview with the magnetometers now, with the source montage. So I see the overview of all channel signals just in one screen. And now I'm going spike hunting, and that works by paging through the data with the gaming keys D and A, and this is already one of the spikes. And if I mark a cursor, I can see that the map becomes active at the bottom right there. And I can see the magnetometer map here, since the source montage is based on magnetometers. But if I click, if I use the G key on the keyboard, I can toggle through the different map types. So this is EEG, toggle again to gradiometer, and I can see there's an artifact from the data. So again, I need to use some tools to get rid of the artifact. This is using this EEG button, and now I can see the data as well in the map. The artifact is gone. and I can switch off again, then the artifact will be back in the data and also in the map. So it's very quick to just automatically correct for these. Good, and now to define this as a spike event, I try and come close to the peak, then check that what the map looks like, and I can also activate these sensors if I want to, using the H key on the keyboard. That will just activate the sensor display. So in this case, we see the magnetometers. I can right click to get to the view of 9 heads, and I can also drag this window out into, for example, onto a second screen, so that I have an even better overview of the maps. Okay, and now with this 9 view, I can quite easily adjust the cursor so to check whether topography becomes spike-like. Then I can press the F4 key to define that as a spike event, and I should now see the event is populating on the right with this newly found spike event. So here we go. And now I think I'm going to move this map window back into the dock. So this is called the docking widget, because these are the widgets in the dock, and then it can just always be there. And this is my next spike that I've just marked. So I think I'm also going to define this as a spike event. I can also do it with a right click and then use the menu there. So there are various options of doing this. And I can see that this has been sorted into group 2, and maybe you also noticed that the map got a bit sharper because the peak position was adjusted. So the position was actually moved slightly to get to the peak, and it was automatically added to a group. We can see now this event has landed in MEG group 2, and the previous event was in MEG group 1, and we're going to see if there's more groups as we move further through the data and find a few more spikes. So this is another one, and that goes into group 3. And move on through the data using the D key. Here we have another one. This topography looks a bit familiar to me. I think I've seen that before, and we'll see it goes back into group 1. And here we have 2 more spikes. This is going to go into group 2 again, yeah. And maybe you can watch the map while the spikes are defined to see how the map gets updated when the spike is adjusted. And then we have another one here. This adjustment can also be switched off, as I showed you before, and there's also a keyboard shortcut if you want to alternate between using the automated finding or not. So here's maybe the last one. No, I want to do another one. So I need to get a few, so to build up a good group and a good group average. So I want to make sure I've got enough to get that going. And I think this is now maybe enough spikes for the moment to go through the further analysis. So I see the event list has populated quite nicely, and now I'm going to move to the group work step. The group work step is where I now sort of do a final review of my sorting into the groups. So I can see all the spikes, all the individual events on the left, all the averages on the right. And I'm going to start with the first spike group and check if this first spike group has been defined adequately. So I think at first glance, it looks like all these signals look quite similar on the left. And on the right-hand side, I can see they correspond to one of the group averages, but not the other 2. And I can use the map to confirm this suspicion. So the map's going to show me the peak topography. So all the 4 single spikes look basically the same, and they resemble the group average 2, group number 1. So there's nothing I need to do here. They're all being adjusted already. This X mark means I can remove this spike from the analysis if I'm not happy with it. And I could also drag it to another group simply by dragging from the left to the right and drop it on one of the group averages. But as I said, I don't think it's necessary here since they've already been defined quite nicely. And we go to the next group. The next group is the group number 2, and I'm also going to look at the maps. So currently the map build-up is still a bit slow, but I think in the final version, this is going to be much faster. Yeah, and anyway, these 4 maps also look very similar. I can just go to the third group and have a look at this one, the final assessment. And in the third group, I only have 2 events. And yeah, they also have the same kind of topography. So I'm actually done with my grouping, and I can move on to now try and model these spikes and find out where the originators are. So I'll go to the model work step. And the first thing I'm going to do is to select the average of the first MEG group. And on the top left, I can see the overplot, and it's a bit messy, so I'm going to scale it down using the up-down keys. And this is the top plot of the overplot. Then we have the maximum channel in the next plot. And this is the channel in the right hemisphere, so we can see main activities in the right. And just for fun, I'm going to think, okay, what about if I selected just the left part of the channels? So I just drag over this left part, and then my max channel gets updated accordingly. So it's no longer one of the rights because they're not part of the selection. But I now clear the selection again and also zoom in a bit to check out my right hemisphere. Just using the mouse wheel, I can zoom in and out of this top view. Okay, and the other 2 plots I can see here are the global field power and the PCA plots. And the PCA shows me how many components do I expect for this particular spike. And up here I can see the channel types that I used for modeling. So I'm combining gradient magnetometers. And here I could have used an EOG artifact as well to add to the model, which I'm not going to do now. I'm just going to model it like that using the fit button. So this is the average of the first group, and now already fitted and localizes here in the right frontal part of the brain. So I can see that in the MRI, and up here I can see the goodness of fit, the global field power, and again the overplot of all channels. So go back to the goodness of fit, and then I've got the PCA again. And here I've got my source waveforms, so I scale them down, again, up-down key, and then have a look at this map of the data. And also now I can look at the map of the model, or the residual, so the difference. So this looks all pretty good. Quite a nice model. And also the fit statistics on the right look promising. So the chi-squared is green, confidence volume is green, goodness of fit and magnitude are all good. And if that is the case, then I can be very confident this is a good fit, and I can promote this spike to be used for the report. And if I do this with an average, like I'm doing now, what it's going to do is it's going to fit all the single spikes in the same group that have not been fitted previously using the exact same parameters. And gives me then an overview of how my individual spikes fare and what the spread is. So again, these are all green, and I'm just going to select the first spike here and then show the group cluster. And the group clustered, it gives me like all the spikes of the one group in a display. And I'm zooming in now to give it a better look. So it looks quite good, but maybe I'm going to select the next spike just to make sure. And also I can update the view from the transverse to the sagittal. Yeah, but in the sagittal view also it looks like they're all in the same area. Just going to select the third and the fourth to make sure that this really is the case. Yeah, and now I think I'm going to move on to the second group. So the second group, I'm going to start with a single spike and do a fit. And this also comes out with a green fit statistics and successful fit. But now I would maybe want to know, okay, I've fitted this at the spike peak. You can see the cursor at 0 milliseconds there. But how about if I use an earlier fit position? So if I now drag this fit position to an earlier time point, will it still give me a good fit, or where is my onset that defines a good fit? Okay, this is obviously not a good fit, so I've dragged it too far to the -13. What I could now do is I use the sequential dipole. So if I check this box and an initial fitting interval is suggested, and using Alt and drag, I can change that interval. And once I'm happy with this interval, then I can press the fit button here, and this will now perform a fit for each time point in this interval and show me the sequence of dipoles that emerge, including the fit statistics for each of these points. And here we go, we have it, and now we can go back in time from the end of the interval using the mouse wheel. You can see how the cursor moves on the top left, and also how the localization moves when I change my time position, and with it the fit statistics. So we can see now as I move to earlier and earlier time points, the fit statistics get worse and worse, and this is obviously not a good fit if I go too far away from the peak. So let me maybe move forward again and see where I can go. This looks like a good time point. Green fit statistics. I'm now 7 milliseconds before the spike peak, and I can promote this spike here too. Okay, now I see in group 3 I've only got 2 spikes, and I want to find another spike that maybe could become a member of group 3. So no problem, I just go back to the review and I browse through again and try and see if I can find another spike in this data. So here, this could be something. Although there seems to be also an eye artifact in this one too, but I'm gonna mark it anyway and then try and analyze it. Where does it go? Yeah, it did end up in group 3, so I'm going to go straight back to the model. And now I'm just going to work with gradiometers for this fit and try and fit this with gradiometers. And now the fit statistics is not so great. So in fact, a very bad fit. And I'm going to go back and try and refine my model. So you can see there's a lot of baseline activity. And what I can do is now, since there is an eye artifact associated with this spike, I can use the eye artifact components in the model to concurrently model the artifact with the spike. So I'm going to redo the fit now. And now I can see actually a totally different fit. So now green fit statistics, and checking this button here, the artifacts, now shows me the source waveforms for the artifact components. There's 2 of them. There's a horizontal and a vertical saccade that is included in this model. And now, yeah, we can check the map again, and also can now promote this spike and make it part of the report. Okay, but I still want to know, is this actually a similar fit result that I get for the other spikes in that group? So let me do the group average again. Group average looks good. Let me promote it. And then check on the cluster of these spikes in the group 3. And what does that look like? Yeah, so that all looks pretty good. They're all in the same area now. So using my artifact component in the fit has really dragged this spike also in the same localization, same location as the other spikes that are part of this group. That's very good. So now I'm going to just promote another spike from group 1, so that I have a single spike from each of the groups defined for the report. And I'm going to leave the other ones out for the moment and go straight to the visualize work step. This is the visualize work step, and here I see only the promoted spikes. Here I have a mixture of averaged and single spikes. I can uncheck this average button, and then I see just the single spikes if I want to, or I can recheck it to see the mixture of averaged and single spikes. And I can also use the brain surface view here, so I can check the brain surface button. Whenever I select a different spike in the event list, you can see how it slices the brain at that point. So for example, the MEG group 2, I can now rotate it. I can change the transparency to make it a bit more visible. There we go. So then I can really get a 3D and 2D impression of where all my different results are located. And this range here at this right side, that's the use of this is that if I want to use only certain time points for my report or for my export, for example, just the onset, and then I can move that range around, and I can see when I move it, then some of the spikes disappear or reappear when I again make it the full range. Okay, I'm going to keep everything now and go to the report part. And on the left-hand side, I see the overview of the current report. Here I can add some text about the medical history of this patient. I can go to the technical summary, provide information. Here I could see screenshots, but I didn't take any. And this is the group events, so the averages that are promoted. So I can see them all here. And similarly, I can see the single events that are promoted. They are listed there, and they are automatically added to the PDF of the report. And finally, in the summary, I can then go and define the conclusion for this, and then finalize my report. All right, so now my status of the epilepsy study is green, it's completed. So I also see the PDF icon there for the report. And I'm not totally finished yet because I've still got other MEG scans here. These are used for pre-surgical functional mapping, the SEF, the AEF, and I can now simply go and review the SEF and let's check when does a map look like an SEF map. This is already quite good. So it's a left median nerve stimulation, and I can change the time using the mouse wheel to 25, 26 milliseconds. This should be about right. Then the model gives me the same information, and I'm going to just adjust the position now a little bit. So this is different from the spike, where the peak is always in the 0, but here, of course, I need to think about the time after stimulus. Then I fit this SEF spike, and I see that it localizes quite well, and also I get a fit statistics here for the average event 2, which is positive. So without further ado, I think I can promote this and go to the visualize, where I simply will check that my range to be included is correct, and then go straight to the report. And again, I'm back at the patient list, and now I have a completed SEF scan 2. I could do the same now with the AEF to get the full load, and I'm going to spare you this because actually this is just a demo, and I'm just going to show you how this is going to work. So if I now control click these two cards, I'm going to get a new card on the right, the summary card. And if I click the create there, as I just did, then I get back to the visualize, and now I see the combination of my epilepsy and the SEF that I just fitted. And you can see them to the left, and down here I've got a chance of changing the ranges again for each of these individual scans. So back to the epilepsy, and I can just simply include everything in my scan. And once I'm happy with the typos that I included in the result, then I can press the export DICOM button, which will then run the export. And when it's finished, it's going to show on the left, export to DICOM succeeded. Okay, so then I also have a final report of this summary, which basically just includes everything I put in the individual reports and puts it together into one large report file. So finalizing this now, I'm going to have a completed summary study of these two scans. And I can see how the link is there provided now. So this is almost the end, but I just wanted to show you one more thing, and that is I didn't show you how to correct the ECG artifact, how that works. So the reason was there was no ECG artifact in that patient. So let me move to this patient here and start the review on this one, and then I can show you just briefly how this automated ECG artifact correction works in practice. I hope this has actually some artifacts. And yeah, here we are in the review, and yes, indeed, it has some artifacts. Let me go to the sensor level and just again show only some of the sensors. So I'm just going to look at the magnetometers for the moment, and you can see here the artifact quite nicely. And if I click this cardiac button, it instantly corrects, and now the artifact is gone. And see the same thing actually in the source montage. So now it's corrected. If I uncheck it again, the artifact comes back. So it's a very quick and easy way using ICA technology with minimal distortion of the other data that's there. Okay, I just want to show you this one. One last word about the dock widgets. There's also a video player, which is not actually part, but which is part of this offering, but there was no video recording with these days. This slide, you didn't see it here. And that is actually the end of this tour de force running through the, and yeah, Toby's back, and also
and also we hand over to Lisa actually.
Exactly. So enough of my talking. So please, Lisa, give us an outlook of what's going to come next.
Yes, thank you very much, Tobias and Harold, for the great presentation. And also thank you for the collaboration. I think it starts to show in the software that we really have had a common goal in this project. I'd like to use just a few minutes to talk about the related software project, MEGFlow, and then some future directions that we have at MEGIN. So MEG Review is for reviewing and analyzing data, and MEGFlow is new platform for clinical MEG and EEG data acquisition. So it is separate software from MEG Review, and it is developed in-house at MEGIN. And what does it have? MEGFlow provides new graphical user interface to the data acquisition, also with workflows and enhanced usability. MEGFlow includes patient database so that all the data are automatically saved to the database, and they are then directly accessed from there by MEG Review. And this way we can also enhance the security of the data. MEGFlow aims to simplify the patient preparation and offers, for example, visually guided digitization workflow step. And during the actual recording, MEGFlow displays the position of the head with respect to the sensor helmet during the whole recording. So it is a great tool to ensure that we actually capture the brain signal the best way we can. In addition, we'll offer video MEG, which is a feature that has been requested a lot. So there we record video that is synchronized then with MEG data, and as Harold just said, that it will be presented then in MEG Review once the video is recorded. For the clinical use, MEGFlow also features standard EEG montages and possibility to annotate data during the recording. And even though we are having two different products, MEGFlow and MEG Review, so these two are kind of connected to the patient database. and thus using MEG review actually requires the MEG flow. And this is also why these two softwares will be then released at the same time. Next slide, please. Thank you. One thing I'd like to emphasize is that the development of these two softwares, it does not end to the first release, but these are software platforms that we continue to develop. And what we will be doing in the future for the next releases, then of course we have a long list of features that we would like to put in there, but I'm highlighting here just a few that are probably coming to the following releases. So we want to have proper montage editor. We want to have multi-dipole modeling that we needed to leave out from the initial version, and then language mapping and automated spike detection algorithms are important. And while BESA is doing the actual implementation, me and the MEGIN team, we will be working with our users, customers. We will collect user feedback and refine the ideas and workflows for the next releases as well. So once you get the software, we want to hear from you. Yeah, this is really a great way to then also impact the next releases. Okay, that's, I think, all that I wanted to say here. I think we would have a good time for some questions.
Yeah, absolutely. So we go over to the question and feedback. Please be reminded, if you want to ask a question, please enter it into the chat. We already have 3 questions here on the chat. And seems like 1 is actually for the MEGIN side, not for our side. It's about MEG flow, and 2 are for our side. So I think we start over with the first question. How do you co-register if MRI is defaced?
Yeah, I think what is currently possible is that you can deactivate some of the surface points from being used in the fit. So I think if it's defaced, you would want to not use any points that are in the face that are no longer represented by the reconstructed skin. So the skin reconstruction will still work on most of the head, just not the frontal part of the face. So then you would right-click on these points, deactivate them, and then you could still do the registration fit, and if necessary, you could still do any manual adjustments afterwards too. So any other comments?
I think that's exactly it, because we had users which already worked in the MEG field, and not in the MEG field, in the EEG field with defaced recordings, and actually this is working. So, but the experience is pretty good with co-registration for these kind of data sets.
Of course, you should always take care that you don't remove part. We've also seen like part of the brain was even removed.
Yeah,
and that is then a bit too much. I think I would not recommend doing that. So I recommend making sure that you at least keep the brain intact when you do the defacing process. Yeah.
Exactly. So the second question was: is it easy to learn to use MEG review, and will there be training available? Yes, so that's the plan, to have training available for that. And it is, as you saw, it's a workflow guided software, so it is actually pretty easy to learn it. So
yeah, there is a bit of a learning curve, but I think it's much less steep than with all the other software packages I have seen in the past. But maybe Lisa, you can say more about that. You've been a user of this software.
Yeah, well, I can say that of course the idea has been that we have also listened to our like new users. So not only the ones that have been using MEG softwares for 10 or more years, so also newcomers to the field, and try to work to have workflows that would guide the user. Also, I would like to say that we have pretty well-documented manual or instructions for use, so it is really useful for learning to use the software. And we will be providing, of course, some training modules, probably both on e-learning and then like traditional training modules. So yes, absolutely.
Okay, then we have another question here. If you can connect several databases as the question number 1, and the question number 2, can you open the MEG recordings with BESA research? That's a clear yes that you can do. So it's the second part, which is easy to answer for us. The first part is back to Lisa to answer that.
Yeah. So in the beginning, the idea is that this is clinical software. So we probably have only the clinical database in the first release, but we are definitely aware of our research users and would like to support them as well. So most probably yes in the future. And maybe I would just say about the second question, so that of course the data can be exported from MEGFlow so that it can be read by any third-party software as well.
Okay, and then we have a fourth question in here. Will there a plugin interface or API for customized workflows? Well, I guess that is something which might be interesting for research users especially. This is something we have to discuss with Megan how we go on with that, and so yeah.
It's
not easy to answer at the moment.
Yeah.
At least for us.
Yeah. Yeah, that needs to be, see if we can put that in the pipeline, or when it goes in the pipeline, we'll need to discuss.
Yes. Then we have another question. Can you do EEG spike analysis too with the MEG review? Yes.
That's a clear yes. I didn't show that for time reasons, but it actually works exactly the same way as for the MEG signals. You can even, if you want, identify your spikes in the EEG, and then you can copy them over to the MEG, so you can model them in either EEG or MEG source localization.
Exactly. And there's another question about the artifact correction. Does it also work for EEG? You saw the two screens basically. On the top you saw the MEG and the EEG on the downside, which was meant to be that way, that we only correct for that window where you are actually working in. And the other window stays uncorrected, because if you want to contrast, for example, a corrected and a not corrected data, because you can display the MEG data in the other window as well if you like. You don't necessarily need to display the EEG data there. So you can contrast data, corrected data to non-corrected data. So yes, it's possible. It's working for EEG as well. Will you provide beamformer in the future? That is an interesting question. Lisa, that's actually for
yes.
you. But so probably have experience.
Yes, yes, we have experience, but we do not have decision yet. So we are definitely planning to have distributed source modeling or beamformer in the future, but yes, no decision. So I cannot guarantee that. Okay, then there is a question about the hardware. So do I need new hardware so that I'm able to use new analysis software?
Do I need new hardware so that I'm able to use the new analysis software? Yeah, it depends on how old your state-of-the-art computer. Sorry, Lisa?
Sorry, Lisa, I didn't hear you there.
Yeah, I think my connection is breaking.
Okay, so for the analysis software from the part of the demand for the hardware, if you have a current offering, a computer which has the usual power we have with a modern computer, you should be able running this software. So I guess you have a hardware specification anyway in the instructions for use, and this can be seen as soon as the software is on the market.
Sure. Then, of course, there is another aspect to that. So MEG review requires MEG flow, and MEG flow itself requires some hardware updates, which are basically the server for the database, some workstation for the software, also video, camera, and everything there. So so if you think about the whole package, so then yes, you do. But Windows laptop, for example, for the MEG review itself should be sufficient if it's a new model.
Yeah, this was running on a Windows laptop.
And not in used one.
Not in use, no. Well used. Yeah.
Well,
Okay.
I think we have no further questions at this time. So I'd just like to say thank you to all of our guests for presenting this excellent masterclass session. And thank you everyone who was attending today. And we hope to see you all again at future MEGIN Masterclasses. Thank you.
Thank you.
Thank you very much.
Thank you very much. Bye.